Let's discuss engine failures that have occurred following maintenance. This is another Aviation Maintenance Safety Minute.
We all know broken or malfunctioning engine controls are a significant cause of engine failure. This chart reflects 181 aircraft accidents caused by engine maintenance issues. Cylinder torque and engine control cables coming adrift were the top two maintenance-induced accident causes, closely followed by loose B-nuts and magneto parts coming adrift.
Here's another common problem with engines. This one here, the magneto shaft sheared off while in flight. And if you look at the way the thing's sheared off, it's kind of unusual. It's almost a polished edge.
I've never seen a mag fail like this. This engine was mounted on our Diamond DA-20C1. It's our primary flight trainer. Pilot was at altitude talking to the controllers when he lost all power and oil pressure. And they were able to direct him back here. And
Made it back safely?
It did make it back safe.
Good.
Here we can see an example of a throttle cable disconnecting in flight. August 27, 2018, about 37 minutes into the flight, the pilot noticed that the engine manifold pressure was dropping along with the airplane's airspeed, consistent with a partial loss of engine power. The engine then experienced a total loss of power while maneuvering for an emergency landing to a nearby airport. The airplane subsequently landed short of the runway and sustained substantial damage to the aft fuselage. Post-accident examination of the engine revealed that the throttle linkage had detached from the throttle arm of the fuel injection servo. The rod-end bearing for the linkage and the throttle arm were intact and undamaged, but the connecting bolt, its associated washer, castellated nut, and cotter key were missing. It is likely that the bolt securing the linkage had not been properly tightened and secured with a cotter pin during the installation. Who would think that a misinstalled clevis pin and cotter key could take down an aircraft? It may not be normal that a landing with one or two operable engines would lead to a catastrophic event, but it did. In this case, disregarding a special instruction from the manufacturer started the chain of events that led to this accident. Fortunately, this was a good landing in that everyone walked away. As seen in this video, the improperly installed clevis pin, the mechanic turning it around from the manufacturer's instructions, led to the pin interfering with other portions of the engine power controls. The airframe manufacturer was very specific about the clevis pin and its orientation to the control system. The power setting for the left engine could not be reduced below full climb power during flight, causing the crew to shut it down and attempting a landing on one engine. The rest of the story had to do with using thrust reversers on one engine, which did not end well. The National Transportation Safety Board determined the probable causes of this accident to be the captain's failure to maintain directional control during landing with one engine inoperative. Contributing to the accident was an improperly installed clevis pin in the left engine power lever, the crew's delay in accurately identifying their heading, and their subsequent selection of a runway with a strong crosswind. Inspection can generally reveal issues with engine controls. Maintainers are required by 14 CFR 43 Appendix D to inspect engine controls during a 100-hour or annual inspection, but they are also easily seen during a pre-flight inspection. Here are some of the things you should check for. Check for worn or fraying control cables. A good way to see if a cable is coming apart is to drag a rag down the cable to see if it catches on any fraying or broken strands. Cotter keys missing, broken, or improperly installed. Control linkage improperly installed or disconnected. B-nuts not installed, loose, or improperly installed. Jam nuts loose. Make it a habit to physically try to turn them with your fingers to see if they are properly tightened.
On your next pre-flight, take the extra time to look for the specific indicators that could lead to a future engine failure. For the FAST team, I'm David Hayes.